Okay, we're live. Hi. It's been kind of a crazy week outside of work, and I haven't been able to stream very much. We should be good for most of today. And I have a few plans. What's this? Yeah, just a few plans for things to do. First thing was... I did have a request to look into TensorDict for what we've been doing here. So I'm going to do that. Basically, folks just wanted to know if we could clean up the way that we're passing all sorts of stuff to the policy. So right now we have, it takes O device, it takes, where is it? It has different return signatures. So can we just clean all this up if we use a TensorDict? First of all, before I waste time on this, I want to know how reasonable this thing is. That sounds reasonable, right? But I think that you're just going to end up moving this block of logic. It won't take very long to do, though, so I can try it at least. Does TensorDict do anything useful? Try with a dict first. Or a simple namespace, maybe. And do namespace. And then we just do this, I guess. Oops. Like. Policy output. Let's see. Dot logits. This. And then this E3B, this doesn't help because we still have to have this in main, right? Oh, and we also need this value flatten. And then I guess now we would do words done. So values, actions, log probs. So this is just policy. O device, hang on, obs equals where's CPU offload? Probably not policy output either, right? Because we need more than just that. Yeah, so I think we just have to call this like sample or whatever. Data, can't be data. It's a little bit sus. And then you're gonna want rewards in here, right? See, and now we have to like, this is so gross. I promised I would give this a genuine try, though right now this is not looking good. You know, I usually trust my intuitions pretty darn well on like why I do and why I don't do things. Sometimes I'm wrong. And sometimes I'm just being wrong and stubborn, but usually not. We will at least make this run. Turn to action. Okay. We're not going to mess with the experience buffers initially. I think we just wanted to try this. I guess that mostly works, right? Yeah. Well, we have to add in a few things. Done. Was it NVIDIA and mask or whatever? Try this. And we'll just start debugging from here. Missing state. I mean, I see why this is convenient, but I don't know if this is good. You know? We'll try for the default model. So what happens here? Okay, so we have observations here. Now this becomes sample. And then we do decode actions, which also take sample. And then we get all the way to forward train. Cool. Train. Which this should be similar. Sample. Assuming we get sample here, right? Same as before. Kind of shitty. Honestly. Well, I don't want to just like do the exact thing that was requested, even if it's going to be shitty, and say here, see, it's shitty. I think I'll try to make this the best version of it I can, and then decide whether I still think it sucks. Okay, so now I just have to do this in the train. What the hell do we do with the batch data now, though? Is it different? LSTM state. Let's just do. Maybe, you know, I'm kind of actually hopeful that there's a version of this that works. It's just not quite this. Hang on a second. I'll be right back. All right. There we go. Literally just becomes this, right? So policy train forward sample. But this is not necessarily good on its own, so we have to do sample value is going to do this. We get to get rid of this block. All right. See if I can get past a little bit more of this then. And now we fail in fail up here still. It shouldn't be calling forward train. It shouldn't. It's calling the wrong function somehow. Cool. That is a policy. Do we call this one or do we call the wrong one somehow? No, we call the right one. And it can't unpack. Attribute logits. Oh, I literally did CPU obs. Okay. Attribute value mean. No attribute B reward block. Experience has no attribute, really? Oh, this might be a P30 thing. Hang on. Yeah, that's thought we had B rewards. No? Let's go just check what it was before I mess with it. It's not trying to get up. 0.8 is nice. One more fork for 100. One more fork for 100. Go fork it now. Oh, did I totally forget about chat? Yeah, I totally forgot about the chat. Well, there's the chat. I don't know if you're still here, Captain. But no, I'm doing something a little different. I'm just doing some refactor stuff. And I always forget to flip it back to stream mode. I have the overlay without the chat that I use for dev meetings where I'm like working on code with people. Oh, nice cleaning up dev branch. I had somebody request, I had a client request that we see if we can like improve just the way the dev experience of like trying new algorithms and stuff, because it's really difficult to have to thread all the data through the model and the train and like the experience buffer and everything. Now their suggestion was to just like throw it all into a TensorDict, which is close to what I'm doing right now. I don't think that's going to be the best thing. I think that's like the anti-pattern of every function just takes a struct and you unpack everything from that giant struct and you have no idea what's where. And it's even worse in Python because it's not a typed struct. But I think we're going to be able to find something to clean it up a fair bit. I mean, basically they took a look at like how we had like 4 different code paths at the moment. And they were like, hey, what the hell? How do you do anything with this? And I sort of said, well, this isn't going to be what stays here, right? This is just for testing. But they said, well, you could just merge all these features and have them out earlier with clean code. If you just threw it all into a TensorDict, you wouldn't have all these code paths. So we're going to see if that's possible. We're going to see if that's possible. But I also really don't like the idea of passing everything as just a TensorDict. I think I might pass extras as a TensorDict or something. So, any extra information that you need above what is normal could go into a TensorDict. So then you have like this extra optional thing for, whatever algorithm experimentation you want. I think that could work. And it doesn't even need to be a TensorDict here, really. I don't think that you get anything from a TensorDict. I think a normal dict would do it, or a namespace. Probably use a puffer namespace. Tough to. Yeah, exactly, right? And that's the thing. It's like, oh, you want to be the framework for this, you want to be the framework for that. And that's what I hear from a lot of industry people. Oh, you're trying to build the framework for this or the framework for that. And yeah, that makes a lot of business sense. Let's like make an ecosystem and lock everybody to that ecosystem. But that's not what I'm trying to do, right? I'm trying to make all this simple and easy. So, I don't care if the result of this is that people use various parts of PufferLib and like they like incorporate it into their own code. I don't care. You can do that. I'd rather not have people feel like they're locked to a big thing that they have to learn. Frameworks suck. Oh, sample. Where's it? State. Oh, I just forgot to extract this. I think that if I were to really try to clean this all up properly, we would get we'd get something substantially simpler. There's just so much stuff to do, man. It's like I also need to eat and exercise and take meetings and stuff. I kind of feel like if I were to just lock myself in a room for 3 weeks, right, and just code and sleep, we'd kind of have a lot of the stuff done already. I guess I just need more contributors to help with the peripheral stuff that I have thinking about. You know that there are at least two more awesome environments that we could have that would be really easy because they would just be ports of existing code, existing well-written code. There's so much stuff that can be done. And I'm always thinking about. And I finally got off of the stupid Overwatch kick, so I'm no longer wasting large quantities of time in, the evening a couple nights a week. I hit gold and said, okay, you know what? I did it. I'm good. Enough games. What M's? Just like CraftX and Kinetics, like the ones from Forrester's Labs. I mean, I wouldn't want to do this without talking to them first, because it's kind of disrespectful to just do a port of somebody's end without talking to them first about it. But we do have a collab with them, and I think it would make them easier to use. Yeah, that's the problem, though. I have a really addictive personality. You can probably tell. So I'll be thinking about that constantly instead of work. Um, so what I try to do, I'm getting better. Over the last couple of years, I've gotten better at reward hacking myself. So what I'm trying to do at the moment is say, okay, let's just rewire that portion where I was thinking about freaking whatever game it is to just thinking about getting myself back in good physical shape, because there's only so much of that you can do before you're tired, and then it just goes right back to RL. So that's what I've been doing. I don't know, games are incredibly addicting to me. Where is this thing, man? They have followed policy to train sample 356. So this gets past none. Oh, because its state is not none. Right. Right. So this is going to be state. Okay. Still none type has no attribute demo. Alright, where is this? Oh, is it just supposed to be none for state? Maybe I should just pass it that way, right? Maybe that's more general anyways. Because that'll let you use different types of RNNs. Actually, now I'm thinking about it. You know, with all the stuff going on lately, one of the most useful things would be to find more people like you and Spencer who just like want to learn RL stuff, have good programming background, and like, you know, can actually take on pretty sizable projects. That's probably one of the most useful damn things at the moment, would be to just to expand that way. But hey, as soon as you're done with Impulse Wars, we will have all sorts of fun stuff for you to get onto. There's honestly so much research right now that's like is relatively accessible and is hugely, hugely valuable to the field. Okay, so that actually runs. And it trains. Perfect. Cool. So this works. I gotta do a couple things real quick, and then I will be back. And we will, now instead of just having it work, we'll actually make this good, and we'll see if this is something we can add to Puffer. Be back in a bit. Camera crashed. Hang on. Gotta love drivers. Okay. Let's do this. So how did this work out for us? I mean, it's kind of okay. It looks like it kind of reduces code paths, I guess. The thing I don't like about this, right? So first of all, it's Python. So it's not like this is a struct or anything. So you can't actually see what's in it. And stuff's going to get added dynamically and all that. So that's not great. And because it's Python, it's a waste to actually bother declaring it as something that looks kind of like a struct. So that's not going to be great either. So you're just going to get past this namespace and you have no idea what's in it. So I guess the alternative here if I just did this a little less aggressively, right? We pass extras. So what if we like undo a little tiny bit of this? Well, how much of it though? Sample logits, right? Maybe let's look at what this was before. So before, entropy, LSTM state. Well, this is the really ridiculous version. We'd actually cleaned that up already a little bit in dev before we even did this, right? Because now it was just this. I guess I could do mean and standard deviation. So what we return logits, values. What about state? State is still the LSTM pathway, right? What if I just use state for everything, right? So you pass in signature will be observation state. returns logits. I think that would do most of the work. Having all these underscores. We also don't need entropy here. That's easy to fix. Yeah, I think you need to at least return something. You can't just have everything be modifying structs in place. So let me try that next. Okay, so instead of doing sample, use state. And we'll take this out. We have action log prob is sample logits. Okay, that's a little better, right? And then this is still fine. State hidden comes out of this. State, what is it? And then reward. This is R. Sample. Oh, bytes. State. R. Something like this. Let's see what this does to the model though. So we pass state. And this can just be none by default, right? So this is observations, state, observations, whatever. And I don't think this even needs state, right? Because you can do like this. Hidden is going to be this. So you just return. And then we do state.hidden. It's hidden. And then what's this? Logits value. Oops. Stupid. Return. Oops. Logits values. Okay, that's easy. And this also needs state. State. And then this doesn't need the 0. And then this forward train is the same exact thing as the other one. All right. Decode actions. We need to now modify this. So this just takes observations. Okay, that's easy. And now this takes, was it hidden? Delete this. These are actually logits, not actions. So we'll do here, values equals PufferLib namespace, value mean. Expand as values. I don't know if we need to do that. I'll move this up here for now. But I don't think we need to do this. So I think this will get cleaned up quite a bit. Because yeah, I don't think that you need to materialize this extra data here, and that'll be a little optimization. Cool, and now we have a uniform API on this. And same thing here, so this is going to be observations and state. And I also forgot to make this state default to none. It's optional. All right, and then we do, so encode observations, this gets hidden, right? And then we do state.hidden equals hidden. No, actually. H equals state lstmh, state lstmc. And this gives you hidden, comma C. And then we do state hidden. And then we do policy is going to return logits values. Return logits and values. Okay. I think that's better. That's like way less magic. State is going to be sample observation equals X. Heck, no, that's weird. State. I don't even think this takes this, does it? No. Where did you get the 3D text drawing code from in Impulse Wars? The RayLib sample. I don't even think you should use that, honestly. Like, it looks bad. I would just get an icon pack. But, this. You can just delete all that code and like put an icon pack in. Using it now to draw ammo count. It looks bad when I zoom in. Sure, you can do that. I think technically you'd want like billboard sprite for that, but you know, whatever you want to do. It'll look weird when you like draw it from different angles otherwise, I would think. $2D doesn't respect zoom. Billboards require a texture. That's annoying. Well, whatever you can do as long as it looks decent. It's fine. Not worth, you know, agonizing over. Okay, now we need to redo this signature. Go get the original signature back. I think I probably jumped the gun on that. We need state at all? Maybe not. Okay. That's better. Hey, what's up? Doing a little bit of refactoring on the clean PufferLib file at the moment. Trying to make it a little bit easier to try out different algorithms and stuff without making a mess of the code. Because the dev branch got really messy with like all the new different algorithmic tidbits I was testing out. So I'm trying to see if there's a way to like do all this and keep it clean and not make it any more complicated. Yeah. Reward should be on same device, huh? Where did that happen? That should have happened up top somewhere. Is there a need for implementing other types of algorithms for benchmarking and research? I mean, possibly. So here's the thing, right? Everybody who's built an RL library for the last decade is like, oh yeah, we need to put all the algorithms in, right? But most of them kind of just suck, so there's not really a point. Really, the thing that we want to have is we want to demonstrate, okay, this is the best algorithm. We have exhaustive experimental evidence. We provide the best algorithm. There's a need for research stuff more than input design. Yeah, for sure. I mean, but not all of these are entirely new algorithms, right? Some of them are just tidbits that you can add on. For instance, a really basic task for somebody would be to go test out different learning rate schedulers, right, on a whole bunch of our environments. Do like a bunch of hyperparam sweeps and say, hey, actually cosine annealing is always better than linear annealing, or cosine annealing is better in 7 out of 10 environments, or like, what should our default be for that, right? And then there's other stuff like we haven't bothered doing any comparison of optimizers yet. We haven't even bothered sweeping the optimizer parameters. I'd like to know how much importance there is there, right? Let me think what else. I mean, there are tons of these little like research tasks around that have just come down to running ablations on stuff. And yeah, I mean, there are possibly bigger things we can be doing with on the algorithm side. I am interested in some off policy stuff. I think that there's definitely value in having a prioritized experience replay. The only issue I have is that most of the methods in that space are just way more complicated than they need to be, and they're kind of obnoxious. So like, is there some way we can get a form of prioritized experience replay in there? Really obvious example of this, right? Like any of our very sparse reward environments, like the mazes, you're going to get a couple lucky solves early in training. Um, but if you don't learn from those, then nothing's going to happen after that. So, you'd like to keep those trajectories in the training buffer and keep learning from those. You can't really do that with PPO as it's written, but maybe you don't have to go all the way to the mess of off policy algorithms either. There's a lot that can be done here. It really just comes down to who's interested in contributing and who wants to actually put in the time to help with these things. Because I'm working as many hours as I can, but I can't do everything. Data to keep in replay buffers. I mean, even if you were to just keep the obvious, outlier, really high value trajectories, that would do something already, right? So here, let me show you something. This thing here, where is it, Apple? So this paper here, they did advantage filtering. So they just got rid of most of the observations that didn't have a high advantage, and that sped up their training a lot. This completely breaks LSTMs though. So you can't use this with any form of method that has memory. And the analog to this would be probably trajectory level or transition level stuff that's done in off policy. So I think that there's something here to this, but it's not trivial to integrate without breaking all your architectures. I have a half dozen of these in my head, right, that need to be tried. I will go through them myself, but the more people we have helping, the faster it gets done. The heck, where is this? Did I branch off the wrong thing? No. Oh, I see. Is this using GPUs? This is using GPUs. I thought that there was a transfer on here though. Somehow this original code worked, right? I just sworn there was something there. Hmm. This isn't CPU. And clamps. Then we store. Oh, that's annoying, but okay. Cool. Now we take, what's it, obs is B, obs this, we get rid of this. And then this is going to give us, what's it, log state here, lstmh. We get logits. What else? Ooh, you have to detach these, don't you? Yes. Okay. That seems wrong to me, honestly, the way that you have to detach these. Maybe not, though, actually, because, yeah, it's on a whole sequence, so we're good. But I've totally broken training somehow. Lovely. Was working before. Come on, what did I break? Something. Do I have to go figure out what was up with the rewards before? Because this is on CPU, right? And it somehow was supposed to have gotten to GPU. I swear there was like a piece of code that did that. Yeah, here, right? Is this? No, this is only for ops. Should have been somewhere. Guess not, though. Okay. I mean, that shouldn't be what's breaking it, though, should it? Probably something stupid. Let me look. Oh, I think I know what it is. Hang on. Probably that. Alright. Did something. Maybe I did the same thing here. Doesn't look like it. It's gotta be something really basic, I would imagine, right? Okay. Maybe it's in here. I messed something dumb up here. Put observations, hidden, decode. Just values, right? That's fine. This is fine. This is fine. Wait. Gotcha. Decode action. Yeah, that's it right there. There we go. Okay, I think that's what the original was doing. Oof. What time is it? 11? I got a little bit more time. I'm gonna take a couple minutes, get myself a new mug of tea, and then we will see whether this is better, how we can clean this up, and whether this actually does anything for us. I'll be right back. Okay. Let's figure this stuff out. Hey, Twitch folks. That definitely reproduces the original. That's a full solve of breakout. Perfect. I mean, I don't think this is bad, right? You have observations and you have state. State's optional if you don't have a recurrent model, right? And you can smuggle whatever you want into state. You have a uniform output API or just output standard. It's just logits and values. There's no special casing to handle. This is better. I'm happy with this. I think this is in fact better. And like the values thing, it's fine. You know, we just dot mean, dot standard deviation. No big deal. I think I'm happy with this. Yeah, this cleans up the code a bit. I think I wasn't too optimistic at the start because like, I think with observations there and like the whole, just everything into that state, it's too much. I think like this is fine. I think let's just fix you know, whatever other stuff I've broken with P3O and with non-recurrent, and then we'll merge this. We don't want to flatten these ones actually. These ones are meant to have indices. Yeah, let's do this. Namespace 52. There's P3O running. This works just fine. And the only thing I think is we might have to do some reshapes for non-recurrent model. Cannot be multiplied, and this is probably in train. Yeah, this is in train. So we forgot there's a reshape in here that has to be done. right here. Yeah, that's it. And there you go. Tiny little model. Why does this thing not kill? No big deal for now. I kind of like this. I think this is fine overall. Simplifies some stuff, and I think it's good. Now technically, would this handle nested ob spaces? There's not really a point. Yeah, I think we'll not mess with that for now. I think we just do this and we're happy. Let's do that for now. And just merge this to dev. All right, cool. That worked. That cleans stuff up a fair bit. Still a little bit of branching, but it's mostly good. Next. Not really an ocean env. Mm. Just gonna make additional stuff here. Make n from config. Yeah, so it loads this file directly. All right. What's this, human? And I think that we don't need to even, I think we can just return this, right? Because it's already a puffer end. That should be fine. Or PufferLib. It's fine. All right. So that should give us this. And then we have this ini file. And we'll see what this does. Oh, does this fail build? This package break? Hang on. The heck? Failed installing wheels. Really? Python kind of sucks sometimes, doesn't it? Looks like a NumPy versioning bug. Setup.py for NumPy. So they just have like some weirdo version of NumPy, I guess. Okay, we can fix that though. I think it's this one. Fork. Okay. Do I have this? No, this is the whole. In GitHub. And what do we do from here? Yeah, bad NumPy version. Perfect, that now works. I should get a load fail. I guess this doesn't have this param, huh? Oh, that's not good. Let's get this config. Yeah, so for whatever reason, the setup doesn't install the Python. So we'll just build this manually. Cannot open. Yeah, that's fine. util.config. It's not packaged correctly. Hmm. Is this util a built-in? There isn't, right? Not crazy. Config from path. It should be here, right? Hang on. Did he link me the main? He linked me. Oh wait, he linked me puffer release. Yeah, he linked me a different branch I didn't notice. It's weird. Yeah, okay, these are the same. It's annoying. Nothing in here. Config from path. It's Hydra. Well, I mean, I don't have to do this right now. I can do like this. I don't see this util file anywhere. Okay. Cool. That's fine for now. Cool, so this is actually still fine. Pull this. Now we're back on dev. 11:30. Lots of stuff to work on. I'm trying to think what next. I mean, I'm going to be back after lunch and meetings and stuff later. But before then, let me think. There's a lot of stuff to figure out. Present. I'd really like to figure out this P3O stuff. There are a lot of different algorithms to fiddle with at the moment. Maybe I will fiddle with P3O a little bit. Did I ever get that new sweep running? Doesn't look like I did. Yeah, no, I didn't, right? Okay, let's do that next then. We'll just run this puff parameter. Oh, right, I have to okay. Still have this puff value in, right? And I still have it here, perfect. So I just had to run something, and I just failed to do that. Let's fix that right now. Okay, that's snake, no big deal. Sweep.train.puff. Okay, so this is part of the sweep here. And I think I just failed to enable P3O, right? Yeah. Hash for breakout mode sweep. Use P3O true. Tag. That should be fine. And the other one that I wanted to run, right, was oops. We'll have to test this locally. But I want to do the atom params. Learning rate, beta, epsilon, weight decay. Let's see. AMS grad. I was going to just do one real quick to see if it makes a big difference. We had 4 parameters and weight decay. And weight decay is 0, so I think we do weight decay separately. Let's just do these in the epsilon. So we'll just do beta. Cool. And then we'll just add these to the sweep. Let's just remove this one. We're not going to use this. Hey, how's it going? Lodge it normal. 5. Oops. 0.9. Was it 999? Yeah, that's fine. Looks reasonable enough, right? Took a break after leaving. I'm going to start up my env. Good luck, man. A lot to learn. Learn quick. One of the best things you can do is just getting really good at general purpose programming. If you do that, you can build whatever the heck you want. including all this RL stuff. We didn't add this to the sweep. Oh, and actually we have epsilon set different here. Are you sweeping all hyperparams? Yes. That is the best way to do it normally. I actually don't think that like E- notation works here, annoyingly enough. Something like this. That still runs. I don't think you actually can in these ini files. I seem to remember not. I could double check, but not a big deal. Isn't it going to be funny if I've been doing all this algorithm work and something stupid like this makes way more of a difference? I honestly wouldn't be surprised at all. E3B, hang on, do I have E3B on? No, I do not. Good. Mode sweep. Neptune, tag, breakout, atom. Just gonna need my token because I just screwed that up. And then we'll have a couple nice sweeps going for the morning. We'll check on those. How long do these usually take? The sweeps? Depends a ton on the settings, but I think at the moment where the average training speed is around like 3 billion steps an hour, so a few hours. Depends how long I set it for. And we're going pretty quick. A million steps a second is like 3.6 billion steps an hour. Some are a little faster, some are a little slower, and that's what we aim for as a baseline. Okay, here's our new P30. It looks like we're already starting to get stuff. Ooh, that's promising. Maybe this will solve all our problems. We will see. And then here, yep, we have this one as well. Perfect. Now we have our sweep set up. We have a couple more things to test. Times 1149. I think we can maybe just think about JE for a few minutes, and then I will go get myself some lunch, followed by exercise, followed by a ton of meetings, and then be back in the evening. It'll be a good morning work block. But I want to think on how's gym going. I mean, it's going. I'm starting to get my compounds back into some form of shape. I'm lifting really light and just doing higher rep stuff. I think I technically have doctor's clearance to just do whatever the hell I want now. But I need to put about 8 pounds of body weight back on, and probably the easiest way to do that's just going to be through like more higher rep training. And then we'll get the strength cycle back going. Been ordering tons of gym equipment as well. But anyways, the one thing I'm still not sure on P30, I guess I can explain this real quick. And to be fair, I don't even know if JE has this property. It probably doesn't. Oops. So if this is your time axis, so this is like time 0 and this is time n, or this is, I guess, t and t plus n. Here, let's just do this is time t, and this is time t plus n. And then this is the gamma. So this is how much of a weight you assign to each step in the future. So how much do you care about reward going into the future? Let's say that you have a gamma curve that looks something like this. Okay? And then you set your algorithm to have this horizon right here. And then you train your models, you fit your hyperparams, and you get optimal hyperparams to this. Okay, but then like if you change your horizon, you have to retune your hyperparameters now, right? Because this weighting here is completely different. So you're going to change all the other hyperparameters in the process. So I was trying to think if there's like a good way I could come up with to avoid this problem in general. Like, is there a way we can have it so that if you increase this horizon, you don't screw up your optimal hyperparameters? I'm not sure if there is. I mean, I guess let's be clear here. I think JE doesn't have this property at all, right? Like if you just... Okay, no, that's actually really interesting. So if you think about it, JE decays all the way up to... Yeah, so JE keeps decaying, but the thing is, it doesn't decay to 0 as fast as you would think. So you compute, like you get your whole trajectory segment like this, so here's all your data. All right, and then you start computing like your GAE going backwards. But then you split this thing up into segments like this for training, right? And the problem is, like, you think, oh yeah, over this segment, it looks like this, but it doesn't. It actually looks like this. So you don't actually decay all the way to 0 over the course of a training segment. So what happens then is if you increase or decrease your batch size, that will dramatically change. I would think that would dramatically change the overall weightings. So if you just double your batch size, right, if you make your this longer or shorter, then suddenly you're going to be adding a lot more reward to this curve over here, which still works, but you have to optimize hyperparam separately. I think this is probably one of the things that makes RL feel really janky though, right? Is like these hyperparameters are coupled in unintuitive ways. So like you can double your batch size and the algorithm stops working, right? And it's because of stuff like this. So I think these are the things that we need to care about here. Gutter sweep still working. Same curve on each training sample. You'd want to have it somehow here. Let's not say you want the same training curve. Let's say that you want hyperparameters to the extent possible not to interact in unintuitive ways. Right? So increasing your batch size should strictly decrease your variance and just make learning work better. For the same number of updates or whatever. It shouldn't have like some weirdo interaction where it screws up the optimal GAE params or something like that. So instead of thinking about this problem in the context of my new algorithm, I could think about this problem in the context of GAE. And that would be a better starting point because that's something, you know, more familiar. So if I were to try to solve this problem for GAE, what would I do? GAE. Yeah, but what type of normalization, right? You got to get very specific. I mean, I guess there is kind of the advantage normalization built into this, right? Yeah, you will. Now here's the question though, right? So is this actually a problem if you normalize the advantage? So as written, right, this is totally screwed. 1 minus gamma term is normal. That's not the normalization, that's discounting. Those are two separate things. And where's there a 1 minus gamma? Oh, this thing? No, this is just them doing just them doing some algebra, right? It reduces to this. So the discount factor, first of all, the discount factor parameter is very poorly named because the real discount factor is not gamma, it's gamma times lambda, which is a huge difference. They use it because this discounting sum of gamma converges to 1 over 1 minus gamma, which would change but they use it because the discounting sum converges to 1 over 1 minus gamma. Oh. Wait, discounting the sum. Did you mean lambda? Because the factor they use here is lambda, not gamma. Lambda, okay. So I see, so this is their normalization. Because the discounting converges, so this sum converges to 1 over 1 minus gamma. Interesting. Well, but then how does this sum converge? They appear because that's what it converges to. Yeah. The k converges to. That's what sum of lambda. Okay, so it's what the interesting. But still, like, if you take, however many of these terms you take makes a difference, doesn't it? Like, this is a single factor. If you take more of these terms or fewer of them, you're still going to have a different magnitude sum. But I think the key here is that, so this is an estimate, right? And then this is attempting to, you train the value function to predict this, right? The value function is trained to predict this quantity here. Wait, what's this? Advantage at infinity. Yeah, so you're training each of these to predict this. I guess there is an additional value term, right? Well, you train the value to predict, what is it, the full thing, right, then? Yeah, you can jump on Discord. Sure. You're on stream, but that's fine. Hello.
Hello, hello. Okay.
Oh, yeah. I always forget because people have different usernames on, on the stream and on Discord. Yeah, I've seen you're on plenty. How's it going?
Yeah, good, thanks.
Yeah, so I'm trying to figure this thing out. I mean, you basically, it's kind of this moving target thing, right? Where the advantage depends on the value function because the value function is trained to predict advantage plus value or whatever, right?
Yeah.
So the question here, right? I think that this formula on its own is broken in the sense that if you just change the batch size or something and therefore you increase the number of steps over which are going into the sum, you should shift the optimal hyperparameters because you're going to change the scale of this, wouldn't you?
Yeah, I think that makes sense.
But in practice, there is a normalization term that is applied to this full thing.
Yeah, okay, so I think we're getting confused because maybe there's two normalization. There's what there is in the GAE paper that you just shown, which is some form of normalization, but also in the CleanRL, if you go, there's a batch of code that shows normalization in the sense where they just remove the mean and divide by the standard deviation.
That's what I was about to go to right here. Yeah, this,
Okay.
right? So is this enough, is the question. Is this enough to make this thing robust to batch size? Because this mean and standard deviation of the advantage, well, the advantage is already subtracting out the value estimate. So would this make it so that regardless of the batch size and stuff that you put in, it's still going to be stable?
I'm not sure.
The standard deviation will also change. So here, because the problem I have with the new algorithm I'm developing is it doesn't converge to zero if you keep taking gamma out further and further, right? And I've tried to actually make it converge to zero, and if you do that, it does worse because it converges too quickly.
Yeah.
So, gamma.
Yeah, if I
Oops.
remember correctly, it converges to the variance of
Yes, of
your
the
rewards,
reward.
right, Chris?
But
Yeah.
so gamma does converge, right? Their gamma does this, but it does it more slowly than most people would expect, right? Like actually,
Yeah.
very often, like the horizon that you're computing it over, you could be computing horizon here. So you actually have, gamma at the end could be like 0.4 or something. You actually have quite a bit of contribution from terms that are pretty far out. Now, mine does not converge to zero. Mine does something, like this or whatever. And then the question is, if you just keep taking this out further and further, right? If you like expand this time horizon so it looks like this, how do you prevent these extra values from messing up your sum?
Mm.
And these are going to be very stable, right? So like, should in theory, should the mean and the mean and variance, like the mean and standard deviation, account for this? Or is this going to like massively reduce the standard deviation and then screw up the stability? Like all this extra stuff here. You're kind of just adding a constant.
Yeah, I mean, in a very naive way, I would just say, so it converges to the variance. So I mean, divide the entire sum by the variance. But I think that's what you
Mm-hmm.
tried, right?
Divide the entire, well, that's the advantage normalization divides the sum by the standard deviation, right?
Yeah, it subtracts the mean, so probably so
Mm-hmm.
basically just centers all the advantages around zero.
Yeah.
But I'm not sure that's really okay. So basically, it rescales them. So okay, it might to some extent fix the the issue you
Yeah.
were talking about, but
I don't even know if this is why we have the issue. All I know for sure, right, is that right now when I have my algorithm and I have good hyperparameters that work and I increase the horizon from here to here, it stops working.
hmm,
Right? But that could be many things, right? Because you're trying to fit in my version of the algorithm, right? You have a value head output that say it has 32 dimensions and you go up to 128 dimensions. There are two places that you use this. One is right here, and if I go to the branch, yeah, so I have this Gaussian NLL right here, and I throw this on. This is the prediction of the reward for each time step going forward. And then this is the actual reward you got, and then here's the variance of your prediction. So
hmm.
this could be a capacity issue, because this is just a lot of data to throw into a model. It's also possible that this is just really noisy, because like,
Yeah. So that yeah.
if you can let's say that there's only enough signal to predict like 8 steps out, which is a pretty common thing, right? And you're predicting 32 to begin with, and then you go up to 128. Like
Yeah.
you're kind of just like fitting. You have the same amount of signal, but you have way more noise, right?
Yeah, exactly. So that's what I was going to say.
Mm-hmm.
I was going to ask you the question: do you see the variance just blows up when you start increasing the horizon of that? Because that's something that you would
Mm-hmm.
probably get. That's something you get in enough mathematical finance, for example, where you just get like basically a trend, but it's just you just add a shitload of noise, which takes up most of what's happening in your data.
Mm-hmm.
And I would assume that there's no real, at least currently, algorithm that is capable of predicting hundred steps in the
No,
future with good accuracy. So
not initially.
I, yeah. So
So I mean, then like the question here, right, is like how do you prevent it from screwing you up? Because it's there's the same amount of signal is there, right, in the first 8 elements or whatever. Um,
mm,
it's just and it's not going to blow up the loss to infinity. Like you're not going to have a problem there if you're taking a mean. What's going to happen is like the proportion of the signal that is actually learnable is going to decrease, and then this is going to converge to like the sum of this will converge to probably like 1 over the standard deviation or just the standard deviation, something like that.
what it I'm trying to just throw any ideas maybe done, but what if you try to remove the variance that would just center your entire curve and make it converge to zero whenever whenever it starts converging to the variance, basically the idea would be to make it converge to zero. So
interesting.
no matter how many steps you add, the new steps will just be weighted by zero anyway, so it doesn't matter.
That might work, because I tried that, but I only tried that in the advantage calculation. I didn't try it in the value loss. So what if we keep this thing for the advantage calculation? Because this shouldn't screw up the advantage calculation, right? This is just adding a constant, and then you're subtracting the mean anyways, right?
Yeah.
So this shouldn't screw up advantage calculation. The only thing it can screw up is probably this value function. And then if we center it for the purpose of this value function, this would be like new value mean minus new value standard deviation, reward block minus like standard deviation, or reward standard deviation, or whatever. Like we could do that, right?
Yeah. Just we need to make sure that I'm not really. So you talk it converges to variance. You're now talking about standard deviation, but just make sure that you center basically it centers around zero, one or the other. But
yeah, it converges to.
It probably converges to the variance. That what makes more sense. But
does it? I thought it converged to the standard deviation.
Can you remind me what's the second thing you're predicting? So you're predicting mean and
so
deviation,
the way it works, right, is normally you just predict a single value that's going to be equal to this advantage function. In our case, we are directly trying to predict the reward for the next n steps, right? And then we also have a head that predicts the variance or the standard deviation, right, of that as well.
Okay. Yeah, so I think the important question is which one? Does it predict you said the variance or the standard deviation? I think
I could have that wrong as well. Should it? Wait, what would it converge to? Does it converge to variance or standard deviation?
Well, I think it depends what the second head is trying to output. So
yeah. Well, the second head can output whichever of those that it wants, right? The loss function itself is Gaussian NLL, and it's trained on the variance.
Let me check the documentation on this one. I mean, with Gaussian, I would expect it to output some sort of standard deviation rather than variance. But
I checked; it does. The input for this is supposed to be variance. I mean, you can implement it either way, right? You just take square root or square.
Yep. It's actually pretty simple to check, right? You just start your algorithm, prints the variance, and prints whatever it converges to at the end, and you just check.
Yeah, it looked to me like it was the standard deviation when I was logging. I could have been
Okay,
wrong.
but I mean, what? Yeah, okay. So first step might be to make sure of this, but then once we have this, the ID stays the same, right? You just remove that, so you center everything around zero, and yeah.
Okay, I mean that's fairly easy to do, and then let's see what that would do. Would you then? I guess you would probably sum this then instead of taking the mean, right? Because the more elements you add, the mean goes down, right? So you shift the value loss.
Yeah. I think you're right.
So if you subtract out the mean here, or the expected. You basically are subtracting out a baseline that's equal to, well, what if you just predict majority or whatever, right? You predict like the frequency of reward. And then when you do that, then the actual magnitude of that sum should be equal to the amount of signal that you have. So you would sum that, and that would give you a clean value loss, potentially.
Yeah, I think that's worth trying. That makes sense, at least in my head, but I'm not sure. Maybe you would need to put that on paper.
Now, the one other thing that I do have running at the moment, which is kind of interesting, we'll see how this compares, because I ran this experiment before, but I did it wrong. So I added just like an alpha term, where in the actual computation of advantage, you subtract out some fraction of, I guess this is the variance, standard deviation squared. Yeah, so I subtract out some fraction of, what is it, 1 over variance. Because gamma term here is, this is 1 over variance, is our gamma. And then here I'm subtracting 1 over the, like, the actual variance of the reward. So this would, like, lerp. Because if you set this to 1, right, if you set this alpha term to 1, then you're basically subtracting a baseline from the advantage calculation itself. But I think that the thing that you proposed is better. Yeah, I think that the thing that you proposed is better. Because this also shifts the advantage calculation of... this also shifts the advantage calculation, not just the loss. Yeah. Cool. The only thing I'm not sure about here is still, you will still get some noise in the loss, even if you subtract the baseline. And
Yes.
the longer steps, the more steps you take, the more noise you get, right? Though this should help a lot. Because I think that's the thing that got me before. When I was trying to subtract this out from the advantage calculation, the noise would sum up to be quite a bit. You subtract the mean, but then there's still a fair bit of noise. Technically,
you said the noise summed up to something? Because I mean, from pure intuition, I would say that there should probably be a white noise somehow, I guess. Because
mean 0.
Yeah.
It could be.
But I mean, even you can take it as a mean 0, right? Because if noise doesn't have mean 0, and then you just add whatever is the mean of the noise to your model, and then makes the noise white.
Okay. I think that makes sense. I think that we'll try this. Obviously, I'm going to let the current experiments run, but maybe later this evening I will see if I can implement that and see if this does anything. Let's see how this puff is doing right at the moment. This is where's it? Breakout. Atom. Man, you gotta love having like 30 experiments already finished in that amount of time. Sample 3-do. Got both Impulse Wars camera modes working. Nice.
Those Impulse Wars pictures look so sick.
The environment is entirely Captain's work. I spent a couple days trying to spruce up the render, and then I handed him a horrible blob of ugly code like, here, you finish it. But yeah.
Moving on to be a UX designer, I see, right?
I mean, it's like, I've done enough graphic stuff for the other ends. I just figured, like, okay, this is an awesome end, but it needs to look the part. Otherwise, people are gonna go, oh, well, this looks too simple. Yeah, so this is what I was worried with, and I think this is what happened before as well. Hang on. Yeah, so this is set to true now. Okay. Well, we'll wait for that to run, and then we'll see later. And let me just, one last thing before I go grab lunch. I want to just check on our atom experiments. It'd be so funny if I've been doing all of this work, and like it turns out that just the most important thing is just freaking sweep atom parameters. I honestly wouldn't even be surprised. Yup. Look at that. Literally. We've run 16 experiments and we have a 67-second solve. Wow. Man, RL is stupid. Okay, yeah, let's see. Captain, go ahead, you can show that thing off. Let's see. Let's hop in here. Man, I don't know why I even bother with all this fancy algorithm stuff when there's just like so many easy wins, right? That literally took me 5 minutes to do that.
Yeah, but I mean, in some sense, it really shows up some the fuckery in RL, and I
Well,
mean
that's the
in
goal to
deep
fix it.
learning in general. Right? Yeah, yeah, sure, but I mean deep learning in general too. Like, yeah,
Mhm.
PPO is super fast and stuff, but I mean, look at how many steps it takes to solve stuff. It still need huge sweeps. I mean,
I mean, I
there's
don't
this
know
weirdness
about
in that.
that. Like, I think that honestly, what just happens is in a lot of the rest of learning, like the problems are just too expensive for people to sweep, so they just don't, right? Like if you
Yeah,
look at
yeah,
all
okay.
of
So it's either too expensive or the algo are not good enough. You know what I mean?
well, this is fair. I don't think that the only piece I see in PPO that's like that is JE, which is why I was working on this algorithm, right? Because if you think about it, like what other hyperparameters are there in RL that you don't have in the rest of deep learning? It's just gamma and
Gamma
lambda.
mainly.
So wait, what did you sweep over and get a faster solve?
Atom parameters,
What did you sweep over, like epsilon or
betas,
just
and epsilon. Yeah.
that made a huge difference?
Yes, massive. It's 16
Oh
experiments
wow.
in and has already beaten our best result so far by 33%.
Of time spent or
Yes,
of what?
67-second solve is our best right now.
Yeah, I wonder if this is something we just set or forget, or this needs to be tuned for every env.
Well, that's the cool thing with Puffer, right? Is that we will, like, what I would like to do once we get everything in a nice steady state is we can just run this on every single environment and
Mm-hmm.
we can find that out for certain.
Yeah, because there's been papers trying to figure this out, but the amount of experiments they did were low, and they
Yeah.
also didn't do actual sweeps. They just like tried. They just did very small grid searches
So we can actually do
basically.
this. And if you're interested in helping, like, this is a
Yeah.
really easy way to contribute to science side. We have the boxes that we have now. We're getting the first 5090 sample machine in probably next week.
Oh, sick.
And then in probably less than a month, I am flying out and moving to the new facility, and I'll spend at least a couple months there. And we're not going to be able to get machines in quickly, but we will have capacity there for 40 machines. So we'll like start buying stuff, right?
Hmm.
And then all those machines will be like for the most part for usage for Puffer and for contributors to do this type of work.
Okay. Nice.
Yeah.
Yeah, I'm definitely down. I'm nearing the finish line of this thing, so I'm excited to
Yeah.
start like just running some basic experiments and stuff.
Yeah. And then
Um,
Spencer was supposed to also be on this, but then I kind of stole him for GPU drive.
yeah, that makes sense.
But
She's
it's
making
still
really
cool
good
because he's
progress
going to
on that.
crush that thing. He's going to like completely
Yeah.
crush their trading speed, and it's going to be hilarious.
I mean, he's already at like 500K, I think he said.
Yeah,
So,
but you have to get
or
the sim to like match theirs. When he matches theirs and 10x's their training speed, it's just like, yeah, GG for the engine.
yeah, that's pretty cool.
Oh, we also
Um,
do have GPU accelerated stuff now, because I had like a 4 hour call with Brennan, the Madrona dev, like for one of his ends that we legitimately cannot do in Puffer fast without his stuff,
hmm,
and he got that
why
bound to
is that?
Puffer in that call, so it'll be fun. It's
So
straight
yeah,
up
I
Call of
was
Duty.
thinking,
Like it's straight up like he
oh
has a Call of Duty env on Call of Duty maps.
gosh, that's so cool.
Yeah, let's
I
see
was
Impulse
actually
Wars.
thinking, yeah, yeah. So I was thinking, I could show it, but why don't? Because you already have it ready. Why don't you just like switch that branch and just try it with the controller?
Do I have my? Not even unpack this thing. Let's see.
Oh, yeah. If you're just plugging it in, it should just be plug and play.
Yeah.
Is it an official Xbox controller?
I think I got something like slightly better. I think I got ones with like Hall effect switches on them.
Oh, okay.
They're supposed
I'm
to be
just
like more
wondering.
precise and anti-drift.
Okay, yeah, I've heard of those. That's cool.
It was cheap.
It was really funny. So one of my friends, I was trying to show Impulse Wars 2, and it wasn't really working on a Mac because like Rayload dependencies were being weird. But anyway, we were like he was showing me this website where you can test the accuracy of your joysticks, and he has like an Xbox Elite controller he paid like a lot of money for,
Yeah.
and I just have like a Switch Pro controller, and I was getting like 5% error or something on my sticks, and he was getting like 12, and he was like dumbfounded.
Yeah, apparently the only the base Xbox controllers are better than a lot of what you can buy out there. Funny enough.
Yeah, and I don't know though. I like my Switch Pro controller. It's pretty good.
Yeah, I don't have do I think I actually do technically have the Switch. That's a long story. I have no idea where that even is. Maybe I don't. I forget if I have that anymore.
Hopefully, it should just work because it's for at least for me on Linux, it's plug and play if I plug it in.
Eh. Oh.
Oh,
Oh, this it's funny. The Xbox button opens Steam.
yeah. You might want to close Steam. Like just close it from like the tab at the top right, like fully close it, because that sometimes like interferes with like Raylib stuff.
Does it? That's funny.
Yeah. At least, yeah. Yeah, you gotta exit Steam. That's weird. There's no like
Oh, we'll
exit
see.
option. Yeah. I mean, worst case, you can just kill the Steam process from the command line. So yeah, switch to, yeah, just
Wait,
dash, and then
what did I
switch to,
do? Unmerged
I don't know.
paths?
This is probably just review comments or something. Just dash it, and
Oh,
then,
CD puffer impulse.
oh, this is different. Okay.
Puffer impulse.
See, that's what happened. There were two different repos. Yeah, so,
I
yeah, there
made the
should be a
second one trying to
branch.
fix the original bug, the merge bug.
Okay.
What's the branch?
It should just be 3D-render, but wait, does git branch not list them all? I can't remember. Yeah.
I think this was a single branch clone.
Oh, 3D rendering.
Yeah. So upstream. No. Ah.
Just check out, git checkout, 3D rendering.
I don't think you can do that.
Yeah, I'm pretty sure you can.
No. I think it's because this
Alright, do
clone
git,
is a single branch.
we'll do git branch tac L, and that'll tell you all the branches. Because just git branch, I think, just tells you the branch you're on.
Yeah, so this only has.
Tac lowercase L.
Yeah.
Yeah, it's not showing up. It's on GitHub. It's pushed. I don't know what's up with your repo.
It was a single branch clone.
What?
You don't know that? -- single branch when you clone?
Oh, why would you do that?
Because it's way faster.
Okay. It's probably just a remote, right? You can probably just change your remote, I bet, but this is fine. And the third clone.
What?
I would just do mine. Don't just because like
Alright, where is it?
It's just cap and space like Impulse Wars.
I accidentally Googled imp.
Oh, and I figured out why you had to install those packages when you're initially doing it. It's
Mm-hmm.
because Raylib is being built from source, whereas in Puffer, you're not building Raylib, you're just linking the archive. So that's why you had to install the additional packages because you're building Raylib from source. So
Does this make, what is it?
so switch branches first. Yeah, just try this. Git switch 3D rendering. That should work. What? Oh, it is yeah, my bad.
Hmm?
This is nice because ZSH you just tab complete. It has like tab complete stuff for Git, so I don't actually ever like have
Oh,
this problem.
underscore.
Yeah, it's underscore. Yeah, you should look into ZSH, man. It's such a nice shell. Yeah, just do make release demo, because the render in debug mode runs really slow, but in release mode it's like very fast. Well, plenty fast enough. But yeah, I thought I had like an optimization issue with the 3D rendering, and then I was like, oh wait, I'm building in debug mode.
Yeah.
But I really didn't think it'd make that much of a difference for rendering, but it does.
We have a lot of janky lights and stuff.
No, I removed all the lights because,
Oh, really?
well, yeah, just because I got Bloom working.
Oh, okay. How's this work? Error?
Oh, you're using the old. You have to go back and remove that thing. Okay, so yeah, really quick. Um, edit the CMake file because yeah, you're using the old GZC version.
What are we
You just search
removing?
for GNU. Just search GNU. Remove that, and then just for safe, just remove where. I mean, what? Yeah, we can try it without where. It builds for me with where, but
Error? OW error.
yeah, yeah. There we go. And then it's just in release demo. Demo. Does it work? Can you? I can't see your guy because your chair's covering it.
Well,
Can you? Is your aim working?
no.
Yeah, it's not detecting your controller if your mouse moving. Yeah, try killing Steam and then restarting it. I've had issues with that before.
Dude, how's this not a thing that you can't kill Steam?
I don't know. I can do it. Like it lets me do it from the top. You can just do kill all Steam or something. I don't
Yeah,
know.
I think I'm gonna have to do that. I like how kill all doesn't even kill it instantly.
Oh, it's still okay. Never mind. Now it disappeared. Hopefully it works now.
Still no.
Uh, yeah, that's weird.
I mean, we'll have to get this to work. But I can
Yeah,
do
I don't know
this.
why. So so this is the dynamic cam. If you want to try like just the straight top down cam, I have you just tab
Oh, I
switch.
like this. This is good. Let's
Yeah,
see
try
how
it.
Bloom is.
Yeah, do you see it like on around the drones and also projectiles?
It's it's not like you don't really get like the full bright projectile effect yet, do you? I mean,
It's
the
I could
projectiles
crank the
look way
bloom up
better,
on them.
but
Hmm?
yeah, the projectiles look way better. You don't get
Yeah,
like,
I think I just need to increase like the amount it blurs basically.
you might still need the lights for like muzzle flare or something.
I think that honestly be too like noisy from a visuals perspective because the original doesn't have that either. Because especially like when you're
Hmm.
shooting a lot, that's just like a lot of flashing.
The original, like, well, the shotgun looked really cool on the version I sent you with like all the lights stacked up.
Yeah, it did, but I think it was just a little too much, honestly. The explosions are the last thing. I have some shaders with looking on Shader Toy I think I'm gonna work with. But yeah, what do you think overall? I've made a lot of like obviously like
Yeah, UI is way better. Did
yeah,
you get a new font? No, you didn't, did you?
no, that won't
You
be hard
should
to edit
probably get
though.
like an appropriate font for this.
Yeah. So yeah, try the other cams. What do you think of that? Just tab.
Probably easier to play, but way worse visually.
Yeah. But I mean, that's you have the option now, which is nice.
No ISO mode.
What do you mean? Oh
Uh,
yeah, I mean I could add that, but not right now.
Yeah, I think you should for viewing purposes. It looks cool.
I mean, if you want it, I can add it. I don't really, honestly, I wouldn't probably use ISO mode at all because it kind of makes it hard.
No,
It's
it's for
harder to
watching
see.
bots, not for playing.
No, I know, but even then, like bots could be covered and you can't really see if they're gonna hit a wall. You know what I mean? Like it's hard to tell like where they are based on
Ooh,
the
shotgun.
isometric angle.
Yeah, I mean, these projectiles look cool.
Yeah, actually, syncing up the 2D because there's actually two cameras. I have a 2D camera for the UI that's following the drones, and I have a 3D camera for everything else. Getting them to sync up wasn't horrible actually. I thought it'd be way worse than it was. Yeah, I don't know why your controller isn't working though. That's annoying.
Linux.
Yeah, probably. I wonder. I'll have to try and get it working on the web again, and then I wonder if it'll just work when you're on the web. Because I've had some times where it works on the web and doesn't, because it's like different controller drivers with web.
Railgun, you can just rail them.
Yeah.
Oh no, he's got the black hole.
Yeah, I need to add a cool effect for that too, because right now you can't really see like the pole radius. But yeah, I think the dynamic cam works pretty well. What do you think?
Yeah.
Yeah, the app looks so cool, man. You add some cyberpunk music on top of it, and then you're.
Yeah, I don't think I'm gonna go with sound effects just because like
Do you want?
I
I'm
mean,
trying to
yeah.
think if it would be better. I like the cubes how you added them. Like you had to do multiple faces for that, probably, right?
What do you mean?
Like, did you have to do a different texture for top or something because it's a rectangle?
Oh no, I basically just stacked them. Like I just draw
Oh,
like
okay.
four
You
of
just
them.
made more. Okay.
Yeah. And it's plenty fast.
This
Yeah, the
railgun's
one other
OP as
thing
fuck.
what is?
This railgun is like overpowered as fuck.
Yeah, it's sometimes hard to hit them though. It depends.
Well, the other
But
thing
yeah,
is
it's
you can do the no gun challenge. Let's see.
like only burst.
Let's see if I can get it. Uh no,
You
I'm
should at
getting
least use a
friggin'
sniper to move. Oh. Yeah, the black hole is pulling you.
yeah, it's cool.
Yeah, I'm really happy with this now because we have like the
All right.
top-down mode for like actual play, and then yeah, this looks pretty cool. I think
Yeah,
this will be cool once we get this released.
it's solid. You did delete all the puffer colors, I see.
Yeah, I need to tweak them. I don't, these aren't the final colors, but I think like the black background works best, honestly. Like
Uh,
gives the most contrast. And yeah, like some of the other, like the puffer cyan in particular, it just there wasn't enough contrast for me. Like you couldn't as easily tell like what kind of type of walls were which and stuff.
that's funny.
Okay, I'm gonna have to leave you guys.
Yeah, I
Thanks.
gotta run as well.
Keep me posted
Yeah,
just
this is
when
awesome.
if that works. I'll
Yeah, I'm
probably
gonna
be
try
asleep
that
because
later
it's different
today.
time.
I mean, we have all the experiments running already. So I'm gonna go do that. I gotta go get food. I gotta go do a bunch of stuff. I've got a bunch of meetings today, and then evening we'll be doing more stuff. So
Yeah.
yeah, thanks you too. And for the folks on Twitch, if you want to check out all of this stuff and even get involved with dev, it's all open source. Puffer.ai, start the GitHub, really helps us out. You can join the Discord. It's just discord.gg/puffer. And you can follow me on X for more RL content.